Let me see if it starts. I had some difficulties. Okay, yes. Today is the 4th, right? So we have a function f of x, which I said x squared minus 1 for x less than or equal to 0, and arc tangent x for x greater than 0. We are asked to graph this function. Remember the first thing. Again, this is to commit to memory. What do I have to determine first when I'm asked to graph a function? The domain. So the domain is given by what I see here. This, in interval notation, is negative infinity to 0. Stop me every time you have a question or doubts. Don't be afraid or shy. This is very clear, is 0 to infinity. This has everything between negative infinity and 0, including 0, and this has everything from 0 and above except 0. Obviously, the domain is written as all real numbers. No union is necessary, because everything is there. So the domain happens to be all real numbers. The next step is I have to present a table of values. And I have to present from negative infinity to infinity. In this chart, I have to put in the key value of x. Which is the key value of x here?
0.
Exactly. 0 is the key value. Under 0, I will put this symbol facing left, and I will put this symbol facing right and touching. Very important. This is not going to happen at all points in time for any function, for all functions. You may have parenthesis, and something else in between those parentheses, so be careful. Are we okay with this so far? Now, although I have it right here, I just want to make sure that I'm using x squared minus 1 for this territory, and I'm using arctangent x for this territory. It's extremely important to understand that. Whatever I graph on this side cannot be extended here. Whatever I graph on this side, it cannot be extended that way. So I need to determine these values left and right for sure. This is x squared, so I'm going to say negative 1. Right? I know how to graph x squared. This is the graph of x squared. And x squared minus 1 will be this. For the entire function, I will not graph the entire function. I have to graph this piece only because it's between negative infinity and 0. When I plug in negative 1, what do I get? Do you all agree with 0? It's negative 1 squared. 1 minus 1 is 0. When I plug in 0, what do I get? Right, as I knew. It's this portion of the graph. Now, on the other side, when I plug in 0, arctangent 0 is 0. And now you can plug in any other value you want. However, the easiest one is to plug in is 1. What angle has tangent 1? So when I plug in 1, I have to find an angle. What angle has tangent 1? Exactly, pi over 4. That's really all I need. However, I do know what happens here and here. And this is extremely important for what follows moving forward. Can anyone tell us for the function x squared minus 1, not this portion, right, because this doesn't exist. X squared minus 1, what is the limit as x approaches negative infinity? What does the function do? So what should I put here? That's it. That's why I insist that you use a chart, maybe not the one I present if you don't like it, but I insist because this will be the limit. You have to have, if you use a vertical chart, you have to have room for this somewhere, right? Good. Now what about this? I already committed arctangent to memory. So as x approaches infinity, remember the graph of arctangent. The function values will approach pi over 2. These will be the limits at infinity or negative infinity. So the function that we're going to graph will have the limit as x approaches negative infinity, positive infinity. And as x approaches positive infinity, the function will approach pi over 2 from below, of course, pi over 2. Okay, so now I'm ready to graph this function. You can say this was difficult. It's a combination of two different functions, true. But we know what to do with a quadratic function. This is way from before, right? And now we said we committed our tangent to memory. We have to dream about our tangent. Okay? So then I know how to graph the function. I start from the left. Not this yet, and not this yet for a moment, but I know that this is y equals pi over 2 is a horizontal asymptote at infinity. At infinity only. So I will graph y equals pi over 2. You can graph it all the way, but it doesn't make any difference. On the left-hand side of the y-axis, it doesn't make any. The function doesn't exist. Okay, so I will graph exactly what I know. Negative 1, 0 is right here. And 0, negative 1 is this point. It is a full point. So I'm done with this side. Since this arctangent doesn't exist on the left-hand side, it doesn't have anything to do with it, but I should not even think of showing everything in the graph. But you can say, well, you shouldn't graph just a portion of a horizontal line. True, that's fine too. Okay, so now on the other side, I have 0, 0, which is an open point. So at 1, the graph pi over 4 is 3.14 divided by 4, so it's under 1, right? And this is the graph. I know I don't have to do anything about it. And of course, the range is from the lowest y value to the largest y value, which is from the lowest y value till the largest y value. Very good. Negative 1 to infinity. Okay. Now we are asked to answer a couple of limits. So we have the domain, we have the range. A limit from the function as x approaches 0 from the right. What will you say? So limit of f of x as x approaches 0 from the right. You will say? 0. Limit of f of x as x approaches 0 from the left. You will say? Negative 1. What do we conclude from here as the limit of the function as x approaches 0 from either side? Correct. Any questions about this problem? Any questions about this problem? Okay. Next problem, the difference quotient. So the difficulties, let's talk about the difficulties I saw here. I saw difficulties in, first of all, presenting a chart. That is absolutely mandatory. Again, I'm emphasizing. Please remember, in this chart, I will add the first and the second derivative in chapter 4. So this chart is extremely important. Okay. Then I saw some difficulties in graphing arctangent. Remember, arctangent has to be committed to memory. It has two horizontal asymptotes, one at one end and one at the other. And they're both positive pi over 2 and negative pi over 2 when I graph the whole function. Okay. And the limit is clear. Perfect. Okay, moving on to the next problem. So we had f of x equals 2x plus 1 over x minus 3. Again, I have to commit to memory the difference quotient. I can't play with that. It's the entire course is based on the difference quotient. I have to remember it. So then the difference quotient is f of x plus h minus f of x divided by h. The only piece that I don't have is, I see 3 pieces. Piece 1, piece 2, piece 3. Which one I don't have? Exactly. This is the one that I have to work on first. This is very clear. It's the function. This is very clear. I can't do anything to a little h. Nothing. So if you want, we can start by determining f of x plus h first. So can anyone dictate f of x plus h already simplified so we can save some time?
2x plus 2h plus 1 over x plus h minus 3.
Okay, now let's stop for a moment. Do we all understand how we determined f of x plus h? You can say, no, I don't see it. Okay. So when I look at this function, let's say you give me this function and you say, tell me what it does. This is what I see. So you're giving me this function, and this is what when I look at it, this is what it tells me. It tells me this, that the argument, whatever it is multiplied by 2. The result is added to 1. The result is divided by the same argument minus 3. So now if you're asking me to find f of x plus h, all I have to do is put x plus h instead of the argument. So f of x plus h will be 2x plus 2h plus 1 over x plus h minus 3. Is this now clear to all of us? Yes? Now what if you ask me to plug in there x squared plus 1? Fine. I will have x squared plus 1, I will have x squared plus 1, I will have x squared plus 1. So I will have 2 times x squared plus 2 plus 1, x squared plus 1 minus 3. Is this understood? Yes? Once I have this expression, I put it in, perform all calculations, and try to simplify it. Ready? Any questions before we move on? Okay. So then 2x plus 2h plus 1 over x plus h minus 3. I copy 2x plus 1 over x minus 3 divided by h. Now the question is, what is my next step? Correct. Awesome. So any questions so far? Everything okay? Everyone? Yes? Yes? James, is this okay? Do we understand how we find that to f of x plus h? Better? Everyone? Jason? Everyone? Okay. Very good. So the next step is indeed the least common denominator. I have many students in the past. I had many students in the past would come to me and say, calculus? Easy. Algebra? Difficult. How is that possible? Without algebra, we can't do much in calculus. Oh, calculus, oh, piece of cake. Algebra, very hard. No, we need this. So, okay, the least common denominator. Can anyone tell us what is the least common denominator?
X plus h minus 3 times x minus 3.
Very good. X minus 3, x plus h minus 3. The order is not important. I prefer putting the smaller one in front, but it doesn't matter. It's not important. Okay. Why is the least common denominator the product of the two? Because they have nothing in common. This is one factor. This is another factor. You can't determine one from the other. So the least common denominator must be the product of the two. Okay, but now I have to worry about what I need the numerator to be multiplied by for the first one and what the numerator of the second one needs to be multiplied by. And the answer is, do we all agree with x minus 3 for the top one, for the first? Because this was multiplied by x minus 3, I have to multiply the top by x minus 3. This was multiplied by this, so I have to multiply the top by the same thing. Now I have to be very careful how I distribute and what I write. Any questions for me? Is everything okay so far? Yes? Okay. Can anyone dictate slowly for everyone to see what we need to come up with at the top? X distribute. Okay. So because I determined the difference quotient, what are the two things that have to happen here for any difference quotient for any function on the planet? Two things have to happen. This I have to commit to memory. Yes, it's the second one. Yes. Which one? Not this one, but this one. Yes. This h must disappear. But what is the first one? That will be the second one. What is the first thing? All the terms with no h must go away. If they don't go away, we made a mistake. So please dictate. 2x squared. So we distributed x to 2x plus. Very good. 2xh. We distributed x to 2h plus x. Now we have to distribute -3 to 3 terms. We're ready. Perfect. Perfect. Very good. So all this thing, these 6 terms, all these 6 terms come from distributing x minus 3 or multiplying x minus 3 by these 3 terms. We got 6 terms. Now we have to be very careful because we have to pay attention to this. Whatever I write, I have to change all the signs into opposite signs. Can anyone other than Joe dictate the next part? Because I know he did it well. So I recommend, since this one has 2 terms and this one 3, I will distribute 2x to these 3 terms and then 1 to these 3 terms. And at the same time, I will not forget to distribute -1. I'm ready when you are.
-2xh.
So
-2x squared.
Perfect.
And then -2xh.
Very good.
Plus 6x.
Very good.
Minus x minus h plus 3.
Very good. I always run out of room. You will always see that. So this does not mean minus minus. This only says to me something else follows. Look for it. Okay, this is not minus minus. It's just minus. Okay. So now we know that the terms, if we did not make any mistakes, the terms with no h must. Good. So please commit that to memory. Put a little star somewhere and just say all terms without h must go away every time I calculate the difference quotient for any function. Good. So can anyone dictate? So I want to mention also, some terms with h may also go away. That's fine, by accident. But definitely the terms with no h must go away. So the positive x with a negative x, the -6x with a positive 6x, the -3 with a positive 3. Perfect. So this is what is left. So you were very close. Okay, I thought there was a little error somewhere. So what is the answer? But everything was good. Okay. -7h over x minus 3, x plus h minus 3, and now this is flipped into 1 over h. As you notice, from the numerator, all terms without h went away. Some of the terms with h went away. That's even better. But we ended up with 7h at the top, which is my negative, so I put it in front. And now I changed h into h over 1 as a fraction, and I flipped it because that's how we divide 2 fractions. A fraction divided by another means copy the fraction from the top and flip and multiply by the bottom fraction. Are we okay with this? Everyone? Yes? What follows next? This is the second very important condition for any difference quotient. What do I do now? Yes, h is divided. Please write 1. Why? Why am I insisting? And I say, please write 1. Why? Because you may think it's 0. I've seen it. So h divided by h is 1. H divided by h is 1. So 7 times 1 times 1 over this times 1 is minus in front. Very good. X minus 3 over x plus h minus 3. We know that the difference quotient is what? What it gives? It gives the rate of change, correct, or the slope of the secant line between 2 points, right? Good. But now what if I want to say, what happens if I bring this point closer and closer, closer and closer to the first one? what happens to h?
It's more important.
Right. So I will say for now, if, or I can already do this. Not even if, because we know the limit operator. What if I ask you now, find the limit? I didn't. So you didn't have to do this part, but I'm asking you now. Let's say as h approaches 0, from this negative 7 over x minus 3 times x plus h minus 3. What do you think this is?
7 over x minus 3.
Exactly. Yes, exactly. So this piece goes away. That's the only thing that goes away. So the answer is negative 7 over x minus 3 squared. And this, you will see, will be something very close, very soon. Okay? And we're going to look at this function a lot. And this function will be added, for this function, I will add another row in that chart. This function gives the slope of the tangent line to the graph of the original function at any point where the function exists and is continuous and differentiable. You don't have to write that part just yet. Okay, so now, how do I address this? I'm given a bunch of conditions. Yes, please.
Make a table.
Yes.
for the
So you're
x
going to
values.
have a problem. There's a problem like this in your next quiz, in your next test, and so on and so forth, right? So let's do this. Ready? Again, why do you think I recommend this chart? Because I think it's more difficult to try to put in all these conditions without organizing them. Okay? So let's get this organized. So obviously, what are the numbers? Obviously, 4 is a key, 0 is a key, and there is nothing else. I don't care about anything else but 0 and 4. Okay? So in my chart, I will have 0 and 4. Okay, I can start with f of 0, which is 2. If f of 0 is 2, then I'm done with this condition. Then I have f of 4, which is 1. Then I'm done with this condition. Agreed so far? Okay. Now, 0 from the left, 2. 0 from the right, 0. 0 from the left, 2. 0 from the right, 0. So obviously there is no need for this because these two numbers are the same. So I can present it as 0 at the top, bracket and 2, and close touching with 0. Because these two numbers are the same. Is this an error? No, you can keep it like this. It's fine. Or you can change it into this, only because these two are the same. Okay, so I put in my chart these two conditions as well. And I only need this. 4 from the left is 3, 4 from the right is 0. 4 from the left is 3, 4 from the right is 0. And I'm done with all conditions. Everything is put in there. Again, I don't have to change this if I don't want to, but there is nothing I can do here. All these three numbers are different. Can't change this. So now it's very clear what I have to do. When I graph this function, I have 0, 1, 2, 3, 4. Zero, comma 2 is this point, and it's a full point for sure. 0, comma 0 is this point, and it's an open point for sure. Okay, so this can be one side. I want to see what happens at 4, and then I'll connect. So at 4, 4, comma 1 is this point. 4, comma 3 is this point. And 4, comma 0 is this point. And I'm done. You can connect it the way you like, as long as all conditions are fulfilled. And all conditions are fulfilled. You don't have to have this. You can even graph something like this. And this going this way, and this going this way. It doesn't matter. We are not given any information under that what we have here. And all conditions are fulfilled. 0, comma 2. The limit from the left is 2. The limit from the right is 0. The limit from the left is 3. The limit from the right is 0. And the function value is 4, comma 1. I mean, the function value at 4 is 1. Do we understand this? I know that one problem is not good enough. But if I show 10 problems for each section, we're not going to get to finish. So that's why I'm recording everything so you can go home and redo these problems. Does it make sense? Okay. Good. So now these two limits. So we have limit as x approaches 3 from the left, 5 minus x over x minus 3. Okay. I'm given a limit to determine what is the first thing that I must do, although it's a little bit of a contradiction because when we say x approaches 3, we do not mean x equals 3. Yes, I have to plug in. I have to. You will see there are so many different types of limits. 1, 2, 3, 4. And I don't know which one it is, right? Because I don't know which one it is, I have to plug in at any point in time. Whatever limit I'm given to calculate, I have to plug it in. I don't tell anybody that I'm plugging in, but I have to plug it in to see what it is. So when I plug in 3, although I'm not allowed to, I plug in 3. 5 minus 3 is 2. I plug in 3 and I get 0. And now I know there are only 2 possible types. An indeterminate case of some sort out of 7, an indeterminate case, or an undefined case. Which one is this? An indeterminate or undefined?
Undefined.
Good. So is there a hope for this limit to exist? Never. This limit could never exist. It's an undefined situation, not an indeterminate situation. The indeterminate, there is no guarantee, but there is hope. But in an undefined situation, there is no hope. This limit can have as an answer DNE, positive infinity or negative infinity, because it's an undefined situation, not an indeterminate situation. Okay, so now I know what to expect. It's a rational function. It would not be this, because the limit is from one side only. This situation could have happened if we had from either side. But it cannot happen if it's from one side, only in a rational function. Okay, so now I have to plug in a number as close as I can to 3 from the left. Please give me a number as close as you can, 3 from the left.
2.9.
Perfect. There is no change here. 5 minus 2.9 is still a positive number. But 2.9 minus 3 becomes what type of number?
Negative.
So now I know exactly what the answer is. If it is negative infinity or positive infinity, automatically, what does x equal 3 mean?
Vertical asymptote.
Of course. It must be a VA, a vertical asymptote, mandatory. If this is 15, if the answer here is 15, that's not a vertical asymptote. But if it's positive infinity or negative infinity, x equals 3 must be a vertical asymptote. And now the last one. Any questions on this? Limit as x approaches 3 sine x minus 3 divided by 7x minus 21. Okay, I said plug it in. I'm given a limit, and I'm asked to determine it. And the first thing I have to do is I have no idea what type it is, so I have to plug it in. So when I plug it in, what do I get at the top? Sine 0 is, that's cosine, 0. And the denominator? 0. What case is this? Indeterminate. Is there hope?
Yes.
Yes. There is no guarantee, but there is definitely hope. Good. What do I do next? There is a very important limit that I committed to memory. What is that limit?
Sine of something over something.
Yes, please.
When the
Bryce?
limit of x approaches 0, sine of x over x is 1.
Correct.
We need to transform
As long as I show that those three quantities are identical and the quantity approaches 0. Good. So I have to show my work. I have to present some changes here. I have to make some algebraic manipulations. So I will write that limit as
x minus 3.
very good. X minus 3 approaches
0.
awesome. So I subtract the 3 from both sides, and I got x minus 3 approaches 0. Perfect. The numerator is 3 sine x minus 3, which I shouldn't do anything because I can't. Sine cannot be distributed to x minus 3. Please don't attempt that. And what do I do in the denominator? I pull out a 7, and I have x minus 3. Awesome. Now, because this quantity, and this quantity are all the same, what will the answer be
1,
for this?
3 over 7.
3 over 7. 3 over 7 multiplied by 1 is 3 over 7. Okay, any questions for me? Yes, please, Joe.
I thought the 3 in the box was that big
Exactly the same. X minus 3,
Oh,
x
it's
minus
not.
3, x minus 3. Exactly the same.
I
And I have to have 0 here. Okay. Oh, and this one here? I'm sorry. I'm sorry. Sorry about that. Is that clear, everyone? So here is your assignment for Thursday. Number 1, I would like you to redo the quiz 1. Okay? I know you have it. I would like you to not just copy it, redo it and check that you get the correct answer. If you still have difficulties, let me know on Thursday, okay? With a difference quotient, with graphing a piecewise defined function, with anything. Yes, please.
Could you do this so you can see all the questions that I think about it?
You're talking about this,
Like all these questions.
this? Yeah, it's going to be posted. Don't worry about it. I'm going to post everything. You're going to have everything posted. Okay, and then I would like half of this, and half of this to be done between now and Thursday. So you choose what half you want, but I want to see half of these problems. Okay? Any questions? So this is what your assignment is, plus this. Okay. Now I would like to continue with the limit laws, and then I would like to look at some examples. So we looked at the sum, the difference, the product, and the ratio. So let's look at another limit law. The limit of a constant times a function as x approaches a from either side. We can put the constant in front because it's a product, and the constant is a factor. So this is the same with C. Limit of f of x as x approaches a from either side. Next limit law, hi Rex. Let's limit law, limit as x approaches a from f of x raised to power n, where n is a positive integer. When we raise a function to a power, that is called a power operator. When we apply a limit of a function, the limit is a limit operator. Under certain conditions, we will see a very important theorem soon. Under certain conditions, they can be swapped. So here, just watch me for a second. I know I look silly, but it may trigger your memory from now on. So this is the power, and this is the limit. I put in the limit inside the power. In other words, the power is on the function, but now it's going to be on top of the limit. On the limit. So I'm swapping this with this. In other words, I put this inside and then n is outside. So it's a swapping operators procedure. And maybe here I should just remind you that we denoted this limit by a number or a letter L in other words, and this is C times L. So this inside is L, so obviously this will be L raised to the nth power. Remember, a limit exists only if it's a number, not infinity. Okay. The same thing with the limit as x approaches a from x to the nth power. You can say, well, this is the same thing. Yes, I will agree. Yes, please, Joe.
Where do you get L?
I'm sorry?
Where did you get L?
From the previous lecture, if you remember, we said that if it exists, let's call it L. If the limit of f of g of x exists, let's call it M. Yeah. So these two are identical because now the function is x. What will you tell me to write? We're swapping the operators again. So this will become power n, and this is limit of x as x approaches a. What do you think the limit of x as x approaches a is?
A.
Of course. So obviously this will be a to the nth power. Here's another one which is pretty similar. Limit of the nth root of f of x as x approaches a. These are all identical. Which limit operators I'm going to swap this time? N is a positive integer. Can anyone dictate? Which operators are we going to swap? What will you say? I would write.
We'll swap the radicals
Exactly, the nth root. So how do I start?
with a large.
The nth root of?
The limit of f of x as x approaches a.
Remember, the swapping of the operators required certain conditions of continuity and so on and so forth. So this is not always possible, but what we do in this class, it will be. So since this is L, this will be the nth root of L. And just one more, the limit of a constant as x approaches a. Who cares where x goes? How much is the limit of the constant? It's still the constant. The limit of 2 is 2, no matter where x is going. Okay. Now if you go to the checklist for a moment, so these are all the limit laws. I recommend you copy them so you have them here for yourself, right? That's what I highly recommend. And now we're talking about the limit of a polynomial. So that's on page 6 at the top. So let's talk about the limit of a polynomial. And there is a theorem there. So if I determine the limit of p of x, p being a polynomial of x, as x approaches a, what do you think the answer would be? Just a wild guess. It's not a wild guess. I'm sure it's an educated guess. What would you think? So before you give me the answer, this is a polynomial. What did we get? What did we really do? We plugged it in. So if we're determining the limit of a polynomial as x approaches a, from either side, from left or from right, doesn't matter, what do you think the answer would be? That's it. P of a. So again, you will say this is a contradiction. You just told us not to plug it in because x approaches a specifically says x does not equal a. True, but the limit can be determined by plugging it in, although x does not equal a. Okay, so this is a theorem for polynomials, not for rational, not for trig, not for functions, not for exponential, not for anything at this point. Although in certain situations we'll be able to do the same thing. Now let's talk a little bit about rational functions. And you can say again, and I will say yes. What type of function is this? Of course. What did we do? We plugged it in because I didn't know what type of limit it was. So we got a positive number over a negative number, so the answer was negative because this is an undefined case. So then what is the general idea for rational functions if I have to find the limit of a rational function? If I get an indeterminate case, then I have to find a value of x as close as possible to 3 from the left. What if I don't get an indeterminate case? For example, what if I have limit as x approaches 2 from x plus 1 over x plus 3? I still have to plug it in. What do I get at the top when I plug it in? What do I get at the bottom when I plug it in? What is the limit? That's it. It's not an undefined situation. It's not an indeterminate situation. So what does this say? Well, a rational function, when I determine the limit of a rational function, I can apply the same procedure that I just applied for polynomials. Only if, there is an if, only if this number is in the domain of the function. Here I don't have any problems. Polynomials are defined everywhere. There's never a situation in which I get an undefined or an indeterminate case for polynomials. There's no headache here, but there's potential headache here. What if I had changed this into x approaches negative 3? Negative 3 is not in the domain of this function. So 3 is not in the domain of this function. That's why I got into trouble, sort of. You know what I mean? I couldn't give an answer because it's negative infinity. So for rational functions, I use the same concept, but only if what? Only if A, this is the general A, is what? In the domain of the rational function. So I have to write this down. Use the same procedure. I'm going to put in parentheses, plug it in, only if, what do I write now? Only if A, you know what I mean, this one, is in the domain, correct, of f of x, indeed. Any questions? Any questions? I'd like to look at some examples. I do have one more theorem to look at, which is the Squeeze Theorem. But before we do that, I'd like to look at examples. On page 107, I marked down in my book all the problems that are recommended by my department, so we can work on some problems. There are even number problems from these. And I'm going to try to avoid the problems that I selected here, which are 12 and 20. So no 12 and no 20, because I would like you to work on those. Okay, so please choose. Again, we're going to have all this. But for now, I just would like to choose 2 problems from these, and then look at the handout. Ready? Which one? Okay, we want to pick 22. What else? And we want to pick 18. Perfect. So for now, let's look at 18 and 22, and then we'll look at the packet that I created. So let's start with 18. We have h approaches 0. So this is limit as h approaches 0 from 2 plus h, everything to the third, minus 8 divided by h. It's a very good pick